Today, we're peeking behind the curtain to look at the invisible strings that guide your every move. We're talking about your brain's autopilot and how you're being trained every single day without even realizing it. I mean, think about it. That little ding or buzz from your phone, before you even have a conscious thought about it, your hand is already reaching for it. Why does that happen? That's not some deep-seated instinct. Nope. It's a powerful, learned, and totally automatic response that has been trained right into you. And this gets to the real heart of the matter. How much of what you do every day is a conscious choice, and how much is just your brain running a program on autopilot? How much of the time are you really in control? Okay, so to get this, we've got to first break down two basic kinds of behavior. You have your innate behaviors. Think of these as your factory settings. They're genetically hardwired from birth. Then you have learned behaviors. This is the software you install over time, the stuff you pick up from experience that lets you adapt to the world around you. And you know what's wild is just how rigid and, frankly, kind of dumb these innate behaviors can be. A gray-log goose, for instance, has a very simple script. See an egg-like thing outside the nest, roll it back in. But the trigger is so basic, so hardwired, that if you put a volleyball next to its own egg, it will choose the volleyball. Why? Because it's bigger. It's a perfect example of a mindless automatic pattern just hijacking the system. But look, these hardwired programs are just the beginning. The real power behind our autopilot comes from what we learn. And this leads us straight to a huge aha moment in psychology, the discovery that we learn by making connections, by association. And it all started with the famous story of Pavlov's dogs. So the fancy term for this is classical conditioning, but really all it is a process of connection. You take something totally neutral, like the sound of a bell, and you pair it again and again with something that's biologically powerful, like food. Do that enough, and pretty soon, the neutral thing, the bell, starts to trigger that biological response all by itself. It's exactly why a simple advertising jingle can suddenly make you crave a soda. So let's break it down. It's really just 3 simple steps. First, before anything happens, food naturally makes a dog salivate. No learning required there, right? That's step 1. Step 2 is the training phase. Pavlov rings a bell right before he gives the dog food, and he does this over and over. Then, step 3, after all that conditioning, the dog's brain has forged a link. Now, just the sound of the bell alone is enough to make the dog salivate. A brand new autopilot response has just been installed. And here's something that's really important to get. This was serious science. This wasn't just some guy in his backyard noticing his dogs were drooling. Pavlov actually performed surgery on the dogs to divert and collect their saliva so he could measure it precisely. He was all about studying observable, measurable reactions, which really helped turn psychology into a much more rigorous science. Okay, so that covers reflexes. You know, the stuff we can't really control. But what about all the things we choose to do, our voluntary actions? Well, that brings us to the second massive discovery about how we learn. We are constantly being shaped by the consequences of our actions, by trial, error, and, of course, reward. This type of learning is called operant conditioning, and the key word there is operate. It means the person or animal operates on their environment. They do something on purpose, and then the outcome of that action, whether it's good or bad, makes them either more or less likely to do it again in the future. And here's the basic playbook. If you want to make a behavior happen more often, you use reinforcement. Positive reinforcement just means you add something good, like giving a dog a treat. Negative reinforcement means you take away something bad, like when you buckle your seatbelt to stop that annoying beeping sound. Now, if you want a behavior to happen less often, you use punishment. Positive punishment is adding something bad, like a scolding. And negative punishment is taking away something good, like a kid's video games. Now, the guys who pioneered this research, like the famous B.F. Skinner, were called behaviorists. And they had this idea that the mind was basically a black box. They were kind of rebelling against the fuzzy, unscientific psychology of their time. They said, look, we can't see thoughts, we can't measure feelings, so we're not going to study them. All that mattered was the observable input, the stimulus, and the measurable output, the behavior. And you know, this super strict focus on only what you can see led to some of the most fascinating and, frankly, bizarre experiments in psychology, which brings us to a really famous one, Skinner's study of the superstitious pigeon. So Skinner had this brilliant, kind of weird question. What happens if rewards are just delivered completely at random? If there's absolutely no connection between what an animal does and when it gets a reward, could you accidentally train it to be superstitious? To figure this out, he put some hungry pigeons inside these specially designed operant conditioning chambers, which we now famously call Skinner boxes. And he hooked them up to a food dispenser that would automatically release a pellet of food. And the setup? Oh, it was genius, just dead simple. The machine would drop a food pellet at a regular interval, say every 15 seconds. And here's the crucial part. The food delivery had absolutely nothing to do with what the pigeon was doing at that moment. The connection was 100% random. The results were just astounding. The pigeons started developing these strange, elaborate little rituals. Whatever a pigeon just happened to be doing when the food dropped, maybe it was turning in a circle or thrusting its head into a corner, it started doing that thing more and more and more, almost like it believed its little ritual was what made the food appear. And this is the big takeaway right here. The birds started acting as if there was a cause and effect link, even when there was absolutely none. Their brains invented a false connection between a totally random behavior and a reward. And well, that's pretty much the definition of a superstition, isn't it? So we've got these two incredibly powerful learning machines running in our brains, learning by association and learning from consequences. So let's bring this all home and see how these things are running in the background of your life every single day. So let's put these two side by side, because this is the core of it all. Classical conditioning is all about association. It links stimuli to create an involuntary, reflexive response. Think Pavlov's dog. Operant conditioning is all about consequences. It uses rewards and punishments to shape voluntary, intentional behavior. Think Skinner's pigeon. Association versus consequence. Involuntary versus voluntary. That's the main difference you need to remember. Okay, so who cares, right? Why does any of this lab stuff matter to you? Because these principles are everywhere. They explain your daily habits, both the good ones and the bad ones. This is the engine that drives effective advertising, which pairs a product with a feeling of happiness. It's exactly how apps are designed, to keep you hooked, giving you unpredictable little rewards to keep you scrolling. And it's the foundation for almost all modern animal training, and a ton of parenting techniques. Which leaves us with one final thought to chew on. Now that you can see the patterns, the invisible associations, and the hidden consequences that shape what you do, take a look at your own life. What parts of your own autopilot can you now see for what they really are?